Hello everyone, hope you're doing fine. Welcome to my channel. Today I'll be discussing a topic in maths that I'm sure most students face problems in, which is calculus. Now, what is calculus? Basically, it refers to the calculations of rates of changes. And why do we even use calculus? It's mainly because most of the phenomena in nature are always changing. So calculus can be used to predict their changes and can be used as mathematical model. So there were mainly two people, Sir Isaac Newton and Gottfried Leibniz, who developed the concept of calculus independently of each other. Before we jump right into the concept of calculus though, it would be best if you have an idea about the concept of gradient or the steepness of a straight line, where in this example this straight line has a gradient of delta y divided by delta x, or simply the change in y coordinates y2 minus y1 divided by change in x coordinates x2 minus x1. It can be also simply remembered as rise over run. So let me demonstrate to you what gradients actually mean. Now let's think about two lines A and B, and if you notice, the line A has a greater slope than that of B. Therefore we can say that the line A has a greater gradient than B. Now let's think of a circle or a graph of function of x and consider a line going through the circle at two different points. For example, x and x plus h. So therefore their corresponding y coordinates would be function of x and function of x plus h. Now these lines are called secants, and let's consider another line on the circle that touches the circle at only one point. So this line would be called a tangent. So let's think about the gradient of the secant, which would be ms equals function of x plus h subtracted by function of x, which is the rise, and divided by h. It's mainly because the horizontal distance would be h only. Now let's consider the distance h. As h tends to 0, or simply as h becomes closer and closer to 0, the secants eventually become a tangent of the circle at this specific point. So the expression of the gradient of the tangent would be mt equals limit as h tends to 0, this guy right here. So this would be the gradient of the tangent at any point on the circle. And this is where the concept of calculus actually begins. So this guy is actually called the gradient function, as this can actually calculate the gradient of any tangents at any point on the circle. So let's think about what happens when y is equals to x. So our gradient function dy dx must be limit as h tends to 0 function of x plus h subtracted by function of x divided by h. So if our initial function was x, so the function of x plus h must be x plus h as well, and function of x is already x. So if you simplify this, the x will be eliminated and you will get h by h. So if you notice, the x terms would cancel out and you'd only get limit of h over h, which is limit as h tends to 0 1. And since there is no h variables, you can simply place value of h here as being 0 and you will get 1, which is actually the gradient of this line, as the equation of a straight line is given as y equals to mx plus c, where m is the gradient and c being the y-intercept. Now let's see what happens when y is equals to x squared. So function of x would be x squared as well, and function of x plus h must be x plus h whole square as well. So let's use the gradient function again. Limit of h tends to 0, function of x plus h subtracted by function of x divided by the h. So if you place this value, you will get x plus h whole square subtracted by x square divided by h, and don't forget your limit here, h tends to 0. Now in order to simplify this, you have to expand x plus h whole square, which is x square plus 2 into x into h plus h square subtracted by x square divided by h. Now if you notice, the x square terms cancel each other out and you get limit as h tends to 0 2x h plus h square divided by h. Now let's further simplify this by removing the h terms. And since the numerator and the denominator have a common factor of h, so we can cancel each other out and get limit of h tends to 0 2x plus h. So if we place the value of h equals to 0 here, we only get 2x plus 0, which is essentially 2x, and that is the gradient function of this y equals to x square. Now if you notice, if you applied the gradient function of y equals to x, then you get 1, and if you applied the gradient function on x square, then you get 2x. So if we summarize our results from the previous examples, if y is a function of x and its equation is in the form of ax to the power n, then dy by dx must be equals to an x to the power n minus 1. And this is our main formula for the gradient function. Now let's do some examples. Let's say if y is equals to this, then find dy by dx. So let's do this systematically. So for number a, we have to find the ddx of 10 x to the power 5. So if y is equals to ax to the power n, then dy by dx must be equals to an x to the power n minus 1. So let's think about 10x to the power 5. So this is in the form of this guy. So if we compare this guy with our ax to the power n, we get a being 10 and n being 5. So the answer would be 10 into 5 x to the power 5 minus 1, or simply written as 50x to the power 4, and that's our answer. Now let's go to number B. So for number B, we have to find the ddx of 1 by x cube. So if we compare this guy with ax to the power n, this is basically not in the same format, so we have to convert this into an index form, which would be in the form of this guy, ax to the power n. So I can write 1 by x cube being x to the power minus 3, if you remember your indices laws. And so now this is in the form of this guy, ax to the power n. So by comparing, you can see that a is equals to 1 and n is equals to minus 3. So using this formula, we can get 1 into, you don't really have to write the 1, minus 3 x to the power minus 3 minus 1. So we get minus 3 x to the power minus 4, which can also be written as minus 3 divided by x to the power 4. So for number C, we have 2 divided by root over x. Now if you compare with y equals to ax to the power n, we do not have the same kind of format. So we have to convert this guy into its index form, which is ax to the power n. So I can write this guy being 2 by x to the power half, because a root is basically the power of half, if you remember your indices laws. And using the same concept as number B, we can write this being 2x to the power minus half. And now we can actually use this formula, dy dx equals to a n x to the power n minus 1, to actually differentiate this expression. So number C would be d dx of 2x to the power minus half, and we get the same formula, 2 into minus half into x to the power minus half minus 1. So as you can see, the 2's cancel out each other and we get minus x to the power minus 3 by 2. And we can also write this in this way, minus 1 by root over x, and then add a cube here because its power is 3 by 2, so half will be the root or the square root and 3 will be the power of the x. So for number D, there are actually 2 terms of x, so we initially have to simplify this and get a single term for x in the form of y equals to ax to the power n. So this will be 5 into x to the power half divided by x to the power 3, or we can also write that by multiplying with x to the power minus 3 so this thing can be written as 5x to the power half minus 3, and when simplified we get 5x to the power minus 5 by 2. So we use that here and write 5x to the power minus 5 by 2, or 2.5, and using the same formula before, we have 5 multiplied by minus 5 by 2 and x to the power minus 5 by 2 subtracted by 1. So if we simplify this, we get minus 25, as 5 into 5 is 25, divided by 2, as none of these terms are divisible by 2, and we get the power of minus 7 by 2. It's better to keep this in this form. For number E, we can directly write those terms being ddx of x to the power 1 by 4 subtracted by x to the power minus 1 by 4, as it is 1 by the 4th root of x. So we can write this being 1 by 4 into x using this formula dy by dx, and 1 by 4 subtracted by 1 minus 1 by 4. Don't forget the minus sign, which is very important, and x to the power minus 1 by 4 which is 1 by 4 x to the power 1 by 4 minus 1 subtracted by minus 1 by 4 into x to the power minus 1 by 4 minus 1, and we get 1 by 4 x to the power minus 3 by 4 plus 1/4 of x to the power minus 5 by 4. Now a quick thing about fraction I'll show you is that let's say we have a fraction like this, minus 1 by 4 minus 1, like in the previous example, like in the last example we did. So how do I simplify this? So the first step of simplifying such fractions is by making sure their denominator, the bottom number, are equal. Here the bottom number is actually 1, because 1 divided by 1 is actually 1. So we make sure that it is also divided by 4. So let's say we have 4 over here. So in order to make the denominator 4, we also have to multiply the numerator, the upper number, with 4 as well, so that the total fraction or the number stays the same, because 4 by 4 is also 1. Because 4 by 4 is also 1. So now the denominators are at the same level, and we can now combine them like this, and we take the common factor of minus 1 here. So we have plus 1 and we have plus 4. So in the end we have minus 5 by 4. So let's say I have another fraction 1/4 subtracted by 1, which was in the previous example, and we have the same rules, 1 by 4 subtracted by 4 by 4, so that the denominators are at the same level, and then we can finally combine them and get 4. There will be 1 and there will be minus 4 here. So basically 1 minus 4 is 3, so we get minus 3 by 4. And this is a short note on how to work with fractions. So now let's move on to the last math problem of this video, where you have to find out the gradient of the curve of y equals to 2 root x plus 1 at point where x equals to 16. So because they told us to find out the gradient of the curve at x equals to 16, first we have to find out the dy by dx, or the gradient function. So we write ddx of 2 root x plus 1. So we have to convert this into an index form, ax to the power n. So we can write this as 2x to the power half plus, as there is 1, we can also write this as x to the power 0. Now let's differentiate this. We get 2 into half. We get 2 into half into x to the power half minus 1, as the formula goes, and as well as this we have 0 into x to the power 0 minus 1. So 2 into half is basically 1, and x to the power half minus 1 is basically x to the power minus half. So this is the index form, and we can also convert it back to its normal form by writing it as 1 by root over x. So when x is equals to 16, our expression of dy dx becomes 1 by root over 16, and root over 16 is basically 4, so the answer is 1 by 4, as this is the gradient of the curve when x is equals to 16. So thank you guys for tuning in to my video about calculus and how to derive from the first principles. So just a quick note guys, if y equals to ax to the power n, dy by dx would be a n x to the power n minus 1. Thank you guys for tuning in to my video about calculus and deriving from first principles. If you have any questions, you can drop your comments in the comments box, which I will check. See you next time in the next video. Take care everyone. Goodbye.